I welcome everyone to this class. This class is about semiconductors. So you might have already some knowledge about the classification of materials. So how the materials are classified? Generally, the materials are classified based on two things: the resistivity and also the band gap according to energy bands of solids theory. So according to energy bands of solids, the gap between valence band and conduction band decides the types of material. If the gap between valence band and conduction band is large enough or larger, the electrons will find difficult to reach from valence band to conduction band. So those materials are categorized as insulators. But whereas in semiconductors, the gap between valence band and conduction band, the gap is actually called forbidden energy gap. The band gap is somehow smaller compared with the insulators. So the electrons can easily move from valence band to conduction band. So the conduction is very much possible. So this is what semiconductors. So the semiconductor lies within the properties of insulator and conductors. All the semiconductors are insulators when the temperature is at 0 Kelvin. When the temperature increased, the electron will get sufficient energy from the temperature and they will move on, or they will move to the valence band to conduction band, move from valence band to conduction band. So thus the conduction happens. Generally, the semiconductors are used in many fields. So semiconductors are finding its application in almost all the fields. If we take microprocessor, memory chips, random access memory, read-only memory, or all the electronics equipments, they possesses the semiconductor devices. So generally, the semiconductors are silicon, germanium. These materials are coming under the category of semiconductors. So why these materials are preferred for manufacturing these electronic gadgets? So that is the biggest question we need to get the clarity. Because the semiconductors are having impeccable property, because it can behave as insulator when the temperature is 0 Kelvin, and it can behave as a conducting material when the temperature is increased. So this particular thing is very much important for constructing many electronic devices. So here nowadays we are finding the most important application of semiconductor is in the mobile technology. So all the mobile phones are having the electronics components which are nothing but the semiconducting materials. So the entire world is heavily focusing the applications of semiconductors. So scientists are carrying out a lot of researches on semiconductor devices to make use of semiconductor materials to fabricate different kinds of electronic components. Now you all know about what are semiconductors. The next thing is how the semiconductors are classified. So predominantly, the semiconductors are classified based on the material. If a semiconducting material is made up of single element, like silicon, germanium, if a semiconductor is made up of single element, that is called elemental semiconductor. On the other hand, if the semiconductors are made up of more than one element, more than single element, having one or two or three elements, that is called compound semiconductors. Example, gallium arsenide or gallium aluminum arsenide. So more than one element, that is called compound. So this classification is based on the material that we are choosing. The next thing is the semiconductors are also classified based on the purity. If the semiconductors are pure in nature without having any impurity, that is called intrinsic semiconductor. The next thing is the other thing, extrinsic semiconductor. If the semiconductors are having any impurities, if the semiconductors underwent any doping process, that semiconductors are called or termed as extrinsic semiconductors. So this extrinsic semiconductor, that is impure semiconductor, further subdivided into two things. One is N-type semiconductor and another is P-type semiconductors. So what is N-type then? When pentavalent impurities are added with the pure semiconductors that will create N-type semiconductor. What are pentavalent impurities? Example, phosphorus, arsenic, antimony. These are pentavalent impurities having 5 electrons at the outermost orbits. So these electrons are making pair with the electrons of the pure silica. So the electrons will be left out. So the electrons are majority charge carriers in N-type semiconductors because we are adding pentavalent impurity. Then what are P-type semiconductors? In P-type semiconductor, we are adding trivalent impurities. Where we added pentavalent in N-type, here we are adding trivalent impurities in P-type semiconductor. So trivalent impurity, boron, aluminum, these are all trivalent impurities having 3 electrons in the valence region. So these 3 electrons making bond with 3 electrons of pure semiconductor, there will be holes left out. So in the previous case, N-type semiconductors, electrons are left out. So electrons are majority charge carriers. There will be more number of electrons. But in this case, P-type semiconductor, there will be lot of holes. So holes are the majority charge carriers in P-type semiconductor. So this is how the semiconductors are classified.